Ahoy hoy, I'm Planetwalk, and recently I was informed that Bill Gaede has made a series of 3-ish minute videos where he talks about science. And when it comes to Bill Gaede, there's two thoughts that I immediately have. The first being, I still don't know how to pronounce his name, maybe I'll find out one day, but as for now, it's one of the mysteries of the universe. I mean, I might actually have the pronunciation right, but I don't know whether it's Bill Gaede or Bill Gaede, so I just use Bill Gaede most of the time. And the second thought that I have is, how wrong has Bill Gaede managed to get everything here? Now I'm going to be responding to the videos in the order that they are uploaded, not in the order that they are in a playlist, because I think the playlist has gotten things backwards, I'm not sure. So let's find out how wrong Bill Gaede has gotten everything, starting with the video, What Science Is Not.
What is this site about? What do we propose here? We propose nothing less than a total overhaul of the scientific method.
I mean, the scientific method has worked pretty well so far since its inception. We've managed to find out quite a bit about the universe, especially over the last couple hundred years.
We argue that science itself has been misconstrued from the start. First by the ancient Greeks, and then by the generation that kick-started the 17th century so-called scientific revolution.
I mean, science is a construct, so there's no inherent way to go about science. The universe doesn't say, this is how science must be done. Essentially, humans thought, okay, what is a good way of finding out more about the universe? And from that, they came up with the scientific method. If you disagree with the scientific method, then sure, feel free to challenge it, but make sure you actually understand what problems the scientific method is trying to solve. Why does that look like word art? I mean, Bill is clearly not a graphic design person, and I may not be one to speak because I'm not either, but it's not difficult to make something better than that. I can do it right now, see? I know presentation and design isn't everything, but you'd think he'd try to at least make it a little bit better, right?
The University of Berkeley Understanding Science site synthesizes for us the notions of science that we ended up with today, since the scientific revolution of the 17th century. Essentially, science is both a body of knowledge and an ongoing process of discovery. And science is useful because it can help us develop new technologies. And yet, this prominent university site lists what causes gravity as one of the questions that no one using the contemporary scientific method has been able to answer in the last 400 years. After 400 years,
you know, the wording there is quite important. It says we don't know the complete answers to these questions. And that is why science is an ongoing process, because, yeah, we have some of the answers, but we don't have all of the answers. To act like there has been no new discoveries in the last 400 years about gravity is just plain wrong. The theories of relativity have definitely played a part in furthering our understanding of gravity. We're now no longer looking for the planet Vulcan, which we thought would exist because of the calculations, but it doesn't exist because at certain distances the calculations were incorrect. Because with relativity, we don't need a planet that doesn't exist in order to explain Mercury's orbit. And sure, there is the issue of galaxies spinning too fast, and we haven't solved that issue, but that might be because we don't have all the answers yet.
Now, how difficult can this be? How is this possible? How is it possible that no think tank on the planet can be able to figure this kindergarten stuff out?
Because it's not exactly easy. You don't just drop something and go, oh, that fell. I guess it's invisible green pixies then. You need to be able to formulate a hypothesis, and that hypothesis needs to be testable. And then you have to test that hypothesis. And doing all that isn't exactly the easiest thing. It can take a lot of expensive equipment sometimes.
I mean, what do we have? We have the Earth and we have the Moon. 2 rocks. And no one can tell you why the Moon remains faithful to our planet and doesn't spontaneously fly away out of the solar system.
Well, that's because Earth bends space-time, and bent space-time can alter the 3D trajectory of an object. So that question has been answered. Maybe try taking a science course.
So if contemporary so-called science cannot answer such a simple question after 400 years, maybe there's something wrong with the notion of science that we have.
Or maybe, just maybe, there is something wrong with your interpretation of what was said on University of Berkeley. Maybe you mixed up "we don't know the complete answers" with "we don't have any answers."
Is science a body of knowledge? Is it an ongoing process of discovery? Is science supposed to be useful? Is the purpose of science to develop new technologies? Does science have anything at all to do with technology? Does science have anything to do with math?
I get that that's a rhetorical question, but all the answers were on the screen right there. You could just, read.
The layman seeks something else. They don't care about equations. What they want to understand is the mechanisms that underlie gravity, magnetism, and other such invisible phenomena. Does the current scientific method meet those expectations?
The thing is though, science can answer those questions. It just may not be fully complete yet. So that was Bill's first video. As you can see, it's not a great start really. But hey, maybe he'll redeem himself in the second video, which is titled "What is Science?" So let's take a look at that.
One way to figure out what science is about is to look up the term in prominent scientific sites, dictionaries, and encyclopedias. Now, it may not be necessary to research all sources, because they all pretty much say the same thing. According to NASA, science consists of observing the world by watching, listening, observing, and recording. Science is curiosity in thoughtful action about the world and how it behaves. For its part, the Collins Dictionary defines science as the study of the nature and behavior of natural things, and the knowledge that we obtain about them. So, what happens if after observing, watching, listening, observing some more, recording, and studying nature, we obtain no knowledge? Does the student graduate as a scientist?
Well, not all scientists are students, and to graduate you need to show that you have an understanding of what you have been taught. Now, to answer the question of what happens if you obtain no knowledge, well, that's a tricky one, because you should obtain at least a tiny amount of knowledge. Even if the knowledge that is obtained is the thing you are doing isn't working, that is still some knowledge. Yeah, it may not necessarily be the knowledge that you're after, but science is all about trial and error. If something doesn't work, well, you now know that it doesn't work, so go back to the drawing board and try something different. It is very difficult for me to think of a scenario in which you wouldn't actually gain any knowledge, unless of course you're doing absolutely terrible science.
We argue instead that science is about proposing rational explanations for how the universe works. This is the goal of science, and this is what laymen want to understand.
Well, that is one part of science, but it's not the only part of science. There is also the fact that you have to test these explanations, and if you can't test these explanations, well, then you're not doing science. It's also worth mentioning that science isn't about laymen, so why do you keep on bringing up laymen? If you want to talk about laymen understanding the universe, well, then that's the job of science communication. You just need to remember that science and science communication, whilst they are linked, they are two different things.
It doesn't matter how much a researcher has observed, watched, or listened, or how many hours they studied, if what comes out of the assembly line are irrational explanations. What have we learned? What was all the studying for?
So if you are doing science well, then you should not get irrational explanations. And also, there is the fact that some things may seem irrational, but we don't fully understand it yet. And in that case, you'll want to do more research into it, because you can't just deny the evidence because you don't understand why you're getting that evidence.
What we need to do now is define what we mean by rational and explanation.
He's really turning his videos into a TV show here, ending his videos with a cliffhanger, because that was just the end of his video there. And yeah, sometimes I do the same, but that's when my videos get quite long. But anyway, let's take a look at the next video, which is titled, "What is a Rational Theory?"
Everyone likes to think of themselves as a rational human being. It is tantamount to an insult, and many a times embarrassing, for you to perceive or sense that your interlocutor thinks of you as an irrational philosopher. But is rationality an issue of opinion? Does irrational mean that you simply don't agree with me?
So far, this is the best video in his series. I don't see much of an issue there. Now, when it comes to a rational theory, I'd say that a rational theory would have to be falsifiable and consistent with evidence. If it does not fit any of those two criteria, then it is irrational. Let's see what Bill Gaede has to say on the subject.
In science, we have to define key words, and rational is one of them, because science is about rational explanations. Science only allows for rational theories.
So the main question I have right here is, why are we using Comic Sans? You have a ton of fonts at your disposal and you chose Comic Sans. There's Alcina, there's Arial, there's Calibri, there's Times New Roman, and you went with Comic Sans. Although, to be fair, maybe it's not a bad thing if he uses Comic Sans in word art, because it's not like he's saying something that's accurate. For example, he says that science is about rational explanations. And yeah, you'll have to have a hypothesis, but that hypothesis doesn't mean anything if it doesn't align with the evidence. What Bill doesn't seem to get is that evidence is the important thing in science, not the hypothesis.
If we cannot even visualize or imagine the phenomenon or mechanism that the speaker is explaining, what have we learned? What have we understood?
So it's not really about visualizing it, it's about understanding it. Yes, visualizing it can help, but it's not the be-all end-all. If you can't visualize something, but you can understand it, then that's more important than being able to visualize it, but not being able to understand it.
Now, the fault sometimes lies with the audience. Maybe they lack the educational prerequisites, the necessary foundations to understand what one is saying. But what about PhDs? Are they off the hook simply because they obtained a 10-year degree?
Well, if you have a PhD, you're far more likely to understand the subject that you have a PhD in than someone who doesn't have a PhD in that subject. Now, that doesn't mean that you're infallible. You can still get things wrong. You are still a human after all. But if you've got a PhD, that at least shows that you have a decent understanding of the subject, because you do need a decent understanding of the subject to be able to get a PhD.
Here we're going to propose that for the purposes of physics, irrationality involves the following criteria. Reifying and moving concepts. For instance, introducing casual figures of speech and worn-out cliches such as transferring information, colliding wave functions, exciting a field, dilating time, and other such euphemisms in the main body of the dissertation.
Those are all things that have been observed though, so are you saying that the universe is irrational? Although, to be fair, one of the things that I haven't heard is colliding wave functions. I have heard of collapsing wave functions and interfering wave functions, but never of colliding wave functions. But the rest of those things all make sense to me, like time dilation, for example. It's a change in the flow of time depending on how fast you're going, or if you're in a gravitational well or something like that. And the thing is, time dilation has been measured. It's why GPS needs to account for it.
Failure to define a key word that makes or breaks your theory, or to use it inconsistently throughout your dissertation. For example, defining energy as capacity and using it as a three-dimensional physical substance in the course of the lecture.
So the first thing is energy is not just capacity. Energy is the capacity to do work. And because a lot of things do have the capacity to do work, that would make them contain energy. Now, I don't think I've ever heard anyone define energy as a substance. I've usually heard it in reference to being contained by something.
The explanation does not follow from the assumptions. The prosecutors introduce a knife as Exhibit A, but their case is that the victim died of poisoning.
That one is mostly fair, but what if the knife actually had poison on the blade and had the fingerprints of the person who was being accused? Maybe that knife was used to open a bottle of poison. If that's the case, then the knife may actually be relevant to the case.
Describing and claiming to have explained. A common error is to think that equations explain. They don't. Mathematics is in its entirety a language of descriptions, It has no power or authority to explain. Since science is about explaining, mathematics plays no role in the branch known as physics.
Oh, that was a very stupid thing to say, Bill. Maths is pretty much essential for physics. If you don't have maths, you don't have physics. There is a reason why Newton invented calculus. In fact, if you have two competing hypotheses, how do you tell them apart? Well, that will be done using maths. Because if you've got different hypotheses, then you'll have different calculations on them, and that means that you should expect different results. Bill is really sounding like someone who wants physics to be simple and doesn't want to have to do all the maths. I'm sorry, but if you want to do physics, you have to do maths. Now, another thing that I take issue with that he said is science only explains, it doesn't describe. Well, I'm sorry, but a description can be an explanation. The only real difference between a description and an explanation is a description is describing how something is. An explanation is answering a question. So if you ask the question of why is the sky blue, you'll receive an explanation of Rayleigh scattering. But Rayleigh scattering is a description of what's happening there. And that description explains why the sky is blue.
Proposed mechanisms don't work or cannot even be imagined. Can matter spontaneously create itself from absolutely nothing, surreptitiously acquiring length, width, and height from total vacuum?
Now it sounds like what he's talking about here are virtual particles, and virtual particles certainly explain certain things like the Casimir effect. Just because you cannot imagine virtual particles doesn't mean that they do not exist. Now it may be that virtual particles don't actually exist and there is some other explanation for the Casimir effect, but you need to actually come up with another explanation for the Casimir effect. Saying I can't imagine virtual particles doesn't cut it.
A film identifying each of the objects on the big screen would certainly go a long way to establish whether the theorist visualized the theory.
Bill, do you know how difficult it can be sometimes to create visualizations? I don't think every scientist has the time to go ahead and create a movie that visualizes the things that they are thinking of. Of course, there are quite a few diagrams, so that might be something that you'll have to settle for, Bill.
These criteria can be used consistently and objectively to determine whether a theory qualifies as rational.
Well, no it can't, because the last thing involved imagination, and imagination is subjective, not objective. So that is that video, but it is not over. I have not finished suffering yet. Now the next video is titled, What is an Explanation? Now I wonder, is he going to make a decent case for an explanation and a description being two completely separate things?
A widespread misconception among lay audiences is that mathematical physics has rational explanations for how our universe works.
Well, if the ideas have been tested and not shown to be false, then yes, it does have rational explanations for how the universe works.
Many recite popular mantras that your computer wouldn't work if quantum mechanics were wrong.
Now, something that I don't think a lot of people realize is that quantum mechanics is not so much a theory to try and explain underlying mechanisms of the universe, it's a description of what we observe. Pretty much all of quantum mechanics is, oh, we observed this thing that happens at a small scale, this is what we found.
And others will tell you that general relativity is correct, because otherwise we wouldn't have developed GPS.
Well, it's not so much that we wouldn't have developed GPS if general relativity was incorrect. It's more that GPS has to account for general relativity, because otherwise it won't work. And the difference between these two statements is that in the latter, if general relativity were false, we could still develop GPS, it just wouldn't have to account for general relativity.
But when you ask the mathematicians, not one can explain to you the physical mechanism that underlies gravity.
I know that you do not believe in space-time, but the curvature of space-time is the mechanism that causes gravity to occur. Or at least that is the best idea that we currently have.
Not one can tell you how one magnet physically attracts another one.
Well, that comes down to magnetic domains. When magnetic domains are aligned, they produce a magnetic field. And when you produce a magnetic field, that can exert a force on other materials. Yes, magnetism is a difficult thing to understand. It can seem like magic. but there are rational explanations for it.
Nobel Prize Richard Feynman is on record stating that, "I can safely say that nobody understands quantum mechanics. Do not keep asking yourself if you can possibly avoid it, but how can it be like that? Nobody knows how it can be like that. The more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. So theoretical physics has given up on that."
And that is why quantum mechanics is all about observation and describing what you have observed.
Another prominent mathematical physicist wrote an article whose title speaks for itself. Even physicists don't understand quantum mechanics. He wrote that if nobody understands quantum mechanics, nobody understands the universe.
So that article that was cited is about how quantum mechanics is weird and we don't know why. And that's because quantum mechanics is a very tricky thing to understand. A lot of the observations that we get don't really make sense to us. But the thing is, you cannot just throw out a whole lot of observations simply because they're inconvenient to you. If you did that, well, then you'd be irrational. And we don't want to be irrational, do we?
An emeritus professor drives home the point in case you missed it. Science doesn't explain. Science describes.
Okay then, enlighten us. How is it impossible for a description to also be an explanation?
All we need to do now is discover the differences between descriptions and explanations. Let's first cover first base. If it's irrational, the explanation is no explanation at all. A theorist should be able to make a movie of the mechanism he or she proposes.
Well, an explanation can be irrational. It just means that it's not a good explanation if it is. Also, I'm using my definition of rational because his definition of rational was irrational. But the thing is, both descriptions and explanations can be irrational. Like if I am describing a dragon, I say it's an invisible green dragon, that is an irrational description. Because if it's invisible, then it's not green. If it's green, well, then it's not invisible.
The audience should be able to watch the mechanism on the big screen.
I'm sorry, Bill, but you're going to have to settle for diagrams because scientists are under no obligation to provide movies to you. They are not film producers, they are scientists. If it's a movie you're wanting, then talk to Peter Jackson.
What images would a theorist put in a film for concepts such as love or energy?
So firstly, in my view, love is a result of us being conscious. And secondly, energy is a property. It's much like how weight is a property. Things will have weight, but that doesn't mean that weight itself is an object.
And this realization leads us to our definition.
Okay, well let's hope that it's a good definition then. It better be better than the definition for rational.
In physics, to explain means to reveal the mechanism that underlies a phenomenon, articulating what caused an event to happen.
Okay, that's fine, but what if you describe the mechanism that underlies a phenomenon? That's still an explanation, right?
An explanation is the prosecutor's version of the causes that underlie the workings of the universe. The theorist paints an objective picture of the scenes necessary to understand the mechanism.
So what do you mean by that? Do you mean that a theorist will describe the things that are necessary to understand the mechanism? It seems like Bill is using poetic language in order to avoid using a word because he decided to play a semantics game. And just to be clear, this is semantics. No matter what the definition of describe or explained is or whether they're different, does not change what science does.
An explanation deals exclusively with the past.
But what if I explain why an eclipse is going to happen? Then that would be an explanation that deals with the future, right?
In contrast, a description is either a robotic listing of properties of an object or a typically chronological recitation of events without identifying the causes.
So yes, a description will typically be a statement of how things are and not deal with causes. And the reason why that is because no matter how much you explain, there is always a question you can ask. Why? Because even if you explain something, you can always ask why. What is the cause of that explanation? I'm sure everyone at least once in their life has played the but why game, where you ask a question and then every time you get an answer, you go, but why? But why? But why? And eventually you'll reach a point where you get no answers, either because the person has gotten really annoyed at you, or because they don't know the answer. So to condense my point, a description may describe the cause of something, but it may not describe the cause of the thing that it is describing.
An equation is just a synthesized description of motion and behavior. An equation has no power or authority to tell you what physical mechanisms underlie phenomena such as gravity and magnetism. Mathematics is exclusively a language of descriptions.
I mean, an equation can tell you why things happen. If you want to know why things break when they fall from a 10-story building, an equation can help you with that. And the thing is, equations allow for specificity. If you do not have any specificity, it makes it very difficult to test your ideas. So you pretty much need equations to be able to test ideas, and if you can't test ideas, then that makes that idea unfalsifiable, and as we've discussed, unfalsifiable ideas are irrational. So that was Bill's 4th video, and as you can probably guess, we're still not done yet. So the 5th video in the series is called Not So Magical Action at a Distance. And it does remind me of the spooky action at a distance. I wonder if it's got any relation to that.
The most popular magic tricks of science typically have to do with magnetism. The performer floats something heavy in the air without anything touching it, and the gullible crowds go ooh and ah.
I mean, I think most people do actually know what magnets are, Bill.
One famous trick has a ball being levitated with magnets. Ordinary folk watch and conclude that magnetism is absolute magic. It seemingly works by remote control. Action at a distance, they call it.
So magnetism may look like magic to some people.
Oops.
But that's only because it's difficult to imagine things being able to interact if they're not touching. But the thing that we don't realize is that when we touch something, we're not actually physically touching it. This is because of repulsive forces between atoms.
Is this really magical action at a distance? What if we could make the invisible mediators that Mother Nature uses to do this trick visible? If we could see that the magnetic field holding the ball up consists of countless threads swinging under it, the trick would no longer be so mystical and incomprehensible.
But the thing is, you cannot make the magnetic field visible. And your idea of there being a whole lot of tiny ropes is just a guess that doesn't really answer any questions. Much in the same way that invisible green pixies doing everything doesn't answer any questions.
Here's another stunning scientific magic trick that wows the crowds. The Earth goes around the sun, and there's nothing between our planet and our star to justify such behavior.
I mean, there is space-time, and the sun does warp that space-time, so that does cause the Earth to move around the sun. So there is a justification.
Of course, if we could make visible the invisible entities Father Universe uses to do this magic trick, it wouldn't be so mysterious now, would it? The only reason people marvel at such tricks is that they can't see the mediators.
I suppose we can try and visualize it, which we have done with space-time. There's a whole lot of different visualizations for that. But again, whether you can visualize it or not has no bearing on what's actually happening.
Laymen reply with what seems obvious to them, that there's nothing there. They can't see or touch the alleged mediators.
So the thing is, there is something there, but it's not the type of thing that our brains can easily comprehend. Our brains have evolved to deal with matter. Things like fields and space-time seem completely foreign to us. But then when you learn and study about these things, it makes it easier to understand what is actually happening.
The fault lies with the crowd's misconceived definition of object. People casually invoke the irrational definition found in all dictionaries and used throughout the world. Object, that which we can touch or see.
So the definition that I found from Googling is a material thing that can be seen or touched. However, there is also another definition that we will get to later.
This definition is irrational because not all objects can be seen or touched. See and touch require a second object. And this is an experiment. You must run an experiment to prove whether the moon is an object. Isn't the moon an object before the asteroid strikes it? Isn't the table that the Klingon has on the other side of the universe an object, in spite of the fact that you can't see or touch it?
So I'd say that in both of those examples, they can be seen or touched, just not necessarily by you. The definition doesn't require that it has to be seen or touched, it just requires that it can be.
An object is not that which you can see or touch. Not all objects can be seen, not all objects can be touched. An object is that which has shape. Shape is a universal attribute. There is not a single object you can imagine that doesn't have shape. And you must define the word object for the purposes of physics, because you can't do physics without an object.
So here is the thing. The definition of object that dictionaries list is the most commonly used definition. And that is because most people want to know how a word is commonly used. It may not necessarily be the scientific definition. So why didn't he use a scientific definition? Now, if I had to guess, it's probably because he wants to say that modern science is irrational. Look how irrational it is. Look at the definition of an object. However, physics has a different definition of an object, and that definition is a collection of matter within a defined contiguous boundary in three-dimensional space. That is a pretty good definition of an object, I must say, one that even Bill might agree with. However, it doesn't seem like Bill has consulted the physics books before talking about physics. So that was the 5th video, and to be honest, not a lot was really said there. But before we continue, because there's more, pat yourself on the back in the comments if you've made it this far. And pat everyone else on the back that has managed to make it this far, because that is a bit of an achievement considering, what we've heard. Anyway, the 6th video is titled, Is Science About Studying? Alright, take it away, Bill.
The Wikipedia defines biology as a branch of science that studies living organisms. And several prominent sites define biology as the study of life. What is interesting is that no one has been able to define the words life and living.
Life is defined as any system capable of performing functions such as eating, metabolizing, excreting, breathing, moving, growing, reproducing, and responding to external stimuli.
Oops.
Maybe actually check to see if anyone has defined the thing that you're claiming that no one has defined.
More fundamental yet, is science about studying? If we look up the word science in dictionaries and encyclopedias, we find the word study almost everywhere.
Well, that would answer your question then, wouldn't it?
The Collins Dictionary defines science as the study of nature and behavior of natural things. And the Wikipedia tells us that natural science is the study of the physical world. Social science is the study of human behavior and functioning of societies. The Oxford Dictionary, in turn, defines study as the devotion of time and attention to gaining knowledge of an academic subject, especially by means of books. And the Collins Dictionary says something similar: to apply the mind to the learning, especially by reading, to study all night.
Just so that everyone's aware, that bit that says to study all night is just an example of it being used in a sentence. It would have helped if Bill Gaede had have made the font just a little bit different to clarify that. Although I suppose I should congratulate him on actually using a decent font this time instead of Comic Sans.
What if you studied all night and didn't understand anything? What if you studied your book all week and got a 0 on the test? Do you qualify as a scientist?
Well, just because you study something, that doesn't mean that you're a scientist. I have studied computers and audio. That does not make me a scientist. And also, devoting time to gaining knowledge does not guarantee the retention of that knowledge. I think anyone who has sat an exam can attest to that.
Is studying just memorizing, regurgitating? Is science like poetry? Reciting mantras you repeat while counting beads on your rosary? So the question you should ask is whether science is learning by rote, which happens to be the way we learn in school. which only perpetuates the status quo.
You know, in Bill's efforts to use semantics to try and undermine current science, he should really read the definitions a bit better. Nowhere in the definition of studying did it say that you have to do it by reading books. It just said that that's the typical way that it is done. Studying can be done by performing experiments, which is something that scientists do when studying. I remember that a large part of my studies were hands-on, especially when it came to things like audio production where you had to set up mics because how else are you going to learn?
And that might explain why contemporary so-called scientists have no answers to questions such as, what is the underlying mechanism of gravity? What causes a magnet to attract another one? Food for thought.
Bill, what do you think scientists do with their time after they graduate? Do you think that they just sit around reading books or something? I mean, sure, reading will definitely be a part of it. There is peer review that has to be done after all. But, you know, you actually have to write papers when you're a scientist. And most likely, you'll also have to do experiments in order to verify the things that you're talking about. Although I suppose, seeing as they're not making movies, that might make all of that invalid, eh? Alright, we are nearing the end. There is just one video left, unless he decides to make another video halfway through me recording a response to this video. I don't think he'll do that, but seeing as this video came out a wee while after all the other videos, there is that possibility. So the last video is titled, Is Science About Knowledge? Let's see what Bill has to say here.
The word science comes from the Latin scientia, meaning knowledge. And knowledge comes from know, meaning to recognize, to become acquainted with. Is science about knowing?
Well, it certainly looks like it has something to do with that, doesn't it?
Wikipedia defines science like most other sources. A systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions about the universe. Testable explanations? This is odd. It's strange because one prominent emeritus professor of mathematical physics tells us otherwise. Science doesn't explain. Science describes.
One day, I hope that Bill Gaede will realize that explaining and describing are two sides of the same coin, and that all he's doing is talking about semantics here. Also, notice how he just brushed over the testable part, which is a very big part of science, testing your hypotheses. I wonder if Bill has ever tested his silly string hypothesis, or if it can even be tested.
Plato defined knowledge as justified true belief. This definition would stay unchallenged for the next 2,400 years. We have made no substantial improvement over it. Knowledge is ultimately nothing but belief. When you know, no one can change your mind because you are absolutely certain of what you know for sure. If someone shows that you were wrong, does your certified knowledge retroactively morph into a belief?
If knowledge is justified true belief, then doesn't that mean that it was always belief? Bill Gaede really needs to pay attention to what he's actually reading. But anyway, if someone shows that your knowledge is wrong, then that will no longer be a justified true belief. Now here is the thing, you can have a justified true belief that is incorrect, because something being true does not mean that it's correct. Although that is quite a philosophical rabbit hole to dive down, which involves talking about what exactly is truth.
The problem is that what you know for sure to be a fact is subjective and personal. Other people might hold different beliefs.
And this is kind of the point that I'm getting at about truth. What one person considers to be true may be entirely different to what another person considers to be true.
Hopefully science is universal and objective.
Well, here's the thing, science can't really be objective. Yes, it is the closest thing that we have to objectivity, but it does have flaws. If science were objective, then it would have no flaws.
We show a movie to a crowd and ask each member of the audience to regurgitate objectively the mechanism they saw. Hopefully, all sane people will state that the box went up because a rope wound around a pulley pulled it up. And hopefully, all sane participants tell you that the glass ended up on the floor because a horseshoe was thrown through the window.
Well, actually, I don't know where the glass ended up in the second one because it doesn't show you. Although, the reality is that no one can objectively tell you what happened there, especially seeing as they're just cartoons. Saying something like, shapes moved around on a screen, well, that's definitely an interpretation of what happened there. And if you really wanted to, you could talk about how the screen produces light, how that light was calculated by the processor, and all that good stuff.
Likewise, if I explain that an astronaut fell to Earth because every atom in his body is bound to every atom that comprises our planet, all participants should be able to explain the same mechanism in their own words.
But the thing is, that is not objective. That is an idea that you have come up with that could be wrong. And actually, in all likelihood, that idea probably is wrong.
Science is objective. Everyone should visualize the same mechanism. Objectivity is not subject to belief. Knowledge.
If science is objective, then science cannot be wrong. Science can be wrong, therefore, science is not objective. But at the end of the day, science is all about furthering knowledge. The science of today could be shown to be false tomorrow. But the only way that we could find out if science is false is by obtaining more knowledge. But anyway, that was the video series that Bill Gaede put out. Let me just check to make sure he hasn't made any new ones. Alright, there are no new ones, so we are safe. But my final thoughts on this is that Bill Gaede is doing the exact same kind of thing that flat earthers do. He's not trying to win the arguments based on evidence. He's trying to win the arguments based on semantics. When you try to redefine the entirety of science to work in your favour, then it becomes a lot easier to win the arguments. But anyway, that was certainly a long video, so make sure you leave a like and subscribe if you enjoyed it, because that will definitely help me out. As always, a big shout out to my $20 or more patrons: Hugh Jarsz, M.C.Nutkin, SHaKie, Wolfie, Morrie, Graymore Ghost, KidVicious, and Sacha Campbell. If you want to support me financially and help me out, you can do so on Patreon. There should be a link right there. But anyway, I will see you in the next video. Between you and me, thank you for watching. With my videos continuously getting longer, one day I might have to create a 7-hour long video. You may laugh, but I wouldn't be the first person to do that.